In Unit 18, Question 1, we're betting on the roll of a die. A die can come up in any of 6 possible ways. And according to the question, the amount we'll win in each case will be the square of the number that appears. For example, if we roll a 1, we'll win 1 times 1, or $1. Let's format that to look like a dollar. And drag down to see what happens in the other cases. Here, for example, we see that when we roll a 5, we'll win 5 times 5, or $25. Now, in this case, the possible outcomes, 1 through 6, are equally likely. So we can find out what amount we should expect to win by playing this game just by taking the average of these 6 numbers in the usual way. We can add them up, divide by 6, and that will tell us the average. If this average number, the amount we expect to win, is more than we pay to play the game, that's $15, then we expect to win on average. And if the average amount is less than 15, we expect to lose. This technique will give us a correct answer for this question. But instead, let's practice the technique shown in the main unit question. This will give us the same answer in this question, but it has the advantage that it will also work when the outcomes are not equally likely. So it's a more general technique and one good to know. We start by calculating the chance of each possible outcome. What's the chance we'll roll a 1? That's easy. On a fair die, it's 1 out of 6. We'll reformat that to look like a percentage, and then copy it to the other cells, since there's a 1/6 chance of rolling any of these numbers, 1 through 6. Now, any of these numbers, say $4, is an amount we might get paid. But we get paid this amount only this percentage of the time. When we play, we don't expect to get the full $4, we expect to get 16% of it. So in this column, we'll calculate the percent of each of the possible winnings. If we add these, we'll get the average amount we expect to win. As noted in the comments for the main question, there's no need to divide. The percentages already include division, since this is 16% out of 100. To add a list of numbers, we start a running total at 0, and then just add on each number in turn. We add on the first number, and then drag to add on the second, third, and so on. Our final answer is $15.17. This is the average amount we expect to win. It's the same number we would have gotten adding these 6 numbers and dividing by 6. Since we pay $15 to play the game, and each time we play, expect on average to win $15.17, we expect to win a total of 17 cents every time we play. And therefore, if we don't mind the risk, it is a good idea to play this game. If we play once, we expect to win 17 cents, although the actual result might be much better or worse. But if we play a large number of times, say 100, we'll come very close to winning 17 cents per time. 17 cents per time over 100 plays would be $17.